The end of materialist science. The cool, clean place. The triple concepts of algorithm, information, and symbol lie at the humming heart of life. How they promote themselves into an organism is something of a mystery, a part of the general mystery by which intelligence achieves its effects. But just how in the scheme of things did these superb symbolic instruments come into existence? Why should there be very complex informational macromolecules at all? We are looking further downward now, toward the laws of physics. Darwin's theory of evolution is widely thought to provide purely a materialistic explanation for the emergence and development of life. But even if this extravagant and silly claim is accepted at face value, no one suggests that theories of evolution are in any sense a fundamental answer to Paley's question. One can very easily imagine a universe rather like the surface of Jupiter, a mass of flaming gases too hot or too insubstantial for the emergence or the flourishing of life. There is in the universe we inhabit a very cozy relationship between the fundamental structure of things and our own boisterous emergence on the scene, something remarked by every physicist. The theory of evolution is yet another station, a place to which complexity has been transferred and from which it must be transferred anew. The fundamental laws of physics describe the clean, cool place from which the world's complexity ultimately arises. What else besides those laws remains? They hold the promise of radical simplicity in a double sense. Within the past quarter century, physicists have come to realize that theories of change may always be expressed in terms of the conservation of certain quantities. Where there is conservation, there is symmetry as well. The behavior of an ordinary triangle in space preserves three rotational symmetries, the vertices of the triangle simply changing positions until the topmost vertex is back where it started. And it preserves three reflectional symmetries as well, as when the triangle is flipped over its altitude. A theory of how the triangle changes its position in space is at the same time, it is one and the same thing, a theory of the quantities conserved by the triangle as it is being rotated or reflected. The appropriate object for the description of the triangle is a structure that exhibits the requisite symmetry. Such are the groups. The fundamental laws of physics, the province of gauge theories, achieve their effect by appealing to symmetries. The physicist looks upon a domain made simple because it's made symmetrical. This sense of simplicity is a sense of simplicity in things. Whether captured fully by the laws of nature or not, symmetry is an objective property of the real world, out there, in some sense of out, and some sense of there. And yet, the world in which we moan and mate is corrupt, fragmented, hopelessly asymmetrical, with even the bilateral symmetry of the human body compromised by two kidneys but one comically misplaced heart, two lungs, one oblate liver. This, too, the fundamental laws of physics explain, those laws miraculously accounting for both purity and corruption in one superb intellectual gesture. The basic expressions of mathematical physics are mathematical equations. Like the familiar equations of high school algebra, they point to an unknown by means of an adroit compilation of connected clues, specification in the dark. But while the equations respect nature's perfect symmetries, their various solutions do not. How can this be? Simple. The equation that some number when squared is 4 has two matched and thus symmetrical solutions, 2 and minus 2. The equation preserves a certain symmetry, but once a particular solution is chosen, some unavoidable bias is introduced, whether positive or negative. So too with the fundamental equations of physics. Their bias is revealed in spontaneous symmetry breaking, our own breathtakingly asymmetrical world the result of a kind of random tilt, one that obscures the world's symmetries even as it breaks them. Such is the Standard Line, its principles governing the Standard Model, the half-completed collection of principles that, like a trusted scout, physicists believe point toward the grand unified theory to come. The laws of nature are radically simple in a second sense. They are, those laws, simple in their structure, exhibiting a shapeliness of mathematical form and a compactness of expression that itself cannot be improved in favor of anything shapelier or more compact. They represent the hard knot into which the world of matter has been compressed. This is to return the discussion to symbols and information, the cross of words throwing a queer but illuminating lurid red light onto the laws of physics. The fundamental laws of physics capture the world's patterns by capturing the play of its symmetries. Where there is pattern and symmetry, there is room for compression, and where room for compression, fundamental laws by which the room is compressed. At the conceptual basement, no further explanation is possible and so no further compression. The fundamental laws of physics are complex in that they are incompressible, but they are simple in that they are short, astonishingly so in that they may be programmed in only a few pages of computer code. They function as tense, tight spasms of information. It is with the fundamental laws of physics that finally Paley's question comes to an end. It is the place where Paley's question must come to an end if we are not to pass with infinite weariness from one set of complicated facts to another. It is thus crucial that they be simple, those laws, so that in surveying what they say, the physicist is tempted no longer to ask for an account of their complexity. Like the mind of God, they must explain themselves. At the same time, they must be complete, explaining everything that is complex. Otherwise, what is their use? And, finally, the fundamental laws must be material, offering an account of spirit and substance, form and function, all of the insubstantial aspects of reality, in terms, metaphorically, of atoms and the void. Otherwise they would not be fundamental laws of physics. Retro. To those committed to its success, contemporary physics has seemed a convergent sequence, a fantastic synthesis of a scientific theory and a moral drama. The grand unified theory is not only a fixed point but a place of blessed if somewhat delayed release. And yet many of the most notable movements in 20th century thought suggest something rather different. The conclusion of almost every grand intellectual progression blocked by incompleteness, or daunting complexity, or a wilderness of mirrors. Any mathematical system rich enough to express ordinary arithmetic, Gödel demonstrated in 1931, is incomplete, some simple arithmetic proposition lying beyond the system's reach. In a result only slightly less fantastic, the Polish logician Alfred Tarski demonstrated that the concept of truth could not be defined within any language in which it is expressed. For that, a retreat to a richer language is required. That language, in turn, requires a still further language for the requisite definition, and so upward along an endless progression, the complete definition of truth beckoning forever and forever out of reach. Until recently, the physical sciences have seemed immune to the retrograde currents so conspicuous elsewhere. But much against their will, physicists have come to suspect that there is a three-way tug, a kind of tension between materialism, on the one hand, and the idea of an unutterably complete but superbly simple theory, on the other. It is at the far margins of speculation that, like oil, anxiety is leaking from the great speculative structures. The universe, so current theory runs, erupted into existence in an explosion. 1 minute there is nothing, the next, poof. Something arises out of nothing, as space and time come into existence and the universe goes on with the business of getting on. An explosion? An explosion in what? Nothing. Nothing? That's right. Nada. Just as there is no point north of the geomagnetic North Pole, Stephen Hawking has observed with some asperity, so there is no time prior to the Big Bang, no space within which the Big Bang took place. Thoughtful men and women have from time immemorial scrupled at this scenario. Theirs is an ancient argument. Something cannot arise from nothing. At the place where the event occurs, the intellect simply goes blank. Explanations rarely help. In the latest version of string theories, Steven Weinberg writes, space and time arise as derived quantities, which do not appear in the fundamental equations of the theory. This is odd, but what follows is odder yet. In these theories, space and time have only an approximate significance. It makes no sense to talk about any time closer to the Big Bang than about a million trillion trillionth of a second. This light-hearted remark suggests that within a certain interval of time it makes no sense to talk of time at all. The effect is rather as if a genial host were loudly to assure a guest that his money is no good while simultaneously endeavoring to take it. Still other physicists repose their confidence in the laws of physics, attributing a strange mystic power to the symbols themselves. Existing in the same undiscoverable realm as Plato's forms, they nonetheless function, those laws, to bring the world into existence. This may seem an exercise in metaphysics of just the sort that, with a fierce wet snort, some physicists routinely deride. It is what other physicists commend. The origin of the Big Bang lies with the laws of physics, Paul Davies insists, and the laws of physics don't exist in space and time at all. They describe the world, they are not in it. The image of the fundamental laws of physics zestfully wrestling with the void to bring the universe into being is one that suggests very little improvement over the accounts given by the ancient Norse, in which the world is revealed to be balanced on the back of a gigantic ox. If this is how explanations come to an end, what of materialism? The laws of physics are sets of symbols, after all, these now vested with the monstrous power to bring things and urges into creation, and symbols belong to the intelligence-infused aspects of the universe. They convey information, they carry meaning, they are part of the human exchange. And yet, it was to have been intelligence itself, and thus complexity, that the laws of physics were to explain, symbols and signs, meanings and messages all accounted for by the behavior of matter in one of its modes.